Hey, what is going on, guys, and welcome back. In this video, we're going to start section 2 under part 4 on more functions. You can find it by clicking the part 4 link here and then section 2 on more functions. I already have VS Code up and running, and I have the exercises open from the TMC tab. So you click on the TMC tab, let it download, and then it will show you the courses. You click on the Python course, then you scroll down to part 4, and you uh, click on the show exercises button. It'll expand down. Make sure you have them all downloaded. I downloaded them off screen. I'm pretty sure I did it in the last video. So if you haven't done that, make sure you download all the exercises so it has them saved on your machine. Then click on the checkbox and open all the exercises if you want, or you can check each individual exercise that you want to cover. So you can go down per section and select the exercises that you need to do for those sections and then open those. Click on the File Explorer here on the at the top left, and it will bring you to this. It will open this side on the gutter, and it will show you all the exercises that you need to that are in that you've decided to open. I decided to open all of them, so they're all listed over here, so I don't have to keep re-downloading them or reopening them every single time I open the workspace. But so yeah, you can do it that way. Uh, you can also track your progress and know which exercises that you have completed already, because it will show you this little green dot on the right hand side. So we did this in the previous video. This was the first exercise that we had to do. We did this on video and we submitted it, got credit for it, and you have this little green dot that tells you that you've have it open. So yeah, this is what I mean. When you click on the TMC button and then click on the left hand side here, it will show you a bunch of options. Click on Python, right? It will show you under my courses, click on Python, and then scroll down, find part 4, hit short exercises. You can click this button here and hit open. It's going to open all 38 exercises under under part 4. Or you can just select the individual exercises that you want. So I went through the course material here on the left. We'll talk about that in a second. And this will be the last exercise in this section. So you can check all of those that you need to do and then hit open and then come back up here, hit the explore button, and it will list them down on over here as it shows it for my computer. Okay. Also, something to remember from the previous video is that these buttons on the top right hand side of the VS Code window, the play button here or the run button will execute the current file that you're working on. You're going to see it printed down here in the terminal. If the terminal isn't open, it'll automatically open it for you and it'll start running your program, and you can interact with your program down here in the terminal. This button is to run the tests. So just like in previous sections when we were doing exercises on the embedded programming window on the course website, right? You hit that run tests button and it'll run your code against all the tests that are prepared for the course, for the exercise. And then if your code passes all those tests, then you get credit for the assignment. Otherwise, it will tell you what errors that you have, and you can go in and fix them again and then resubmit and get credit for that if the tests pass one more time. So that's what this button does. This is just the action menu. It has some options you can do from the TMC extension. I doubt we're gonna need to use this ever, but you do have an option here to reset the exercise. Reset exercise. So that was also a feature that was available on the embedded programming window on the website here, where you can reset your exercise and it will take you back to the start of the exercise where none of your code that you've put into the embedded editor was pasted in there. So it will completely reset your window. So you can do that, but we're really gonna have to click on this tab at all. But yeah, so section 2, we're gonna be talking more about functions. Again, just a heads up, VS Code eats up a lot of memory, at least on my machine for whatever reason. I'm trying to run it pretty lean. I've disabled virtually every extension that I have that I use for other purposes when I'm programming, just to keep it pretty lean, because when I have VS Code running along with OBS and Google Chrome, That's like 80% of my memory is being used up by just those 3 applications. So I'm trying to run it pretty lean, but throughout the video, we might have some frames being dropped. You might hear some choppiness in my voice. Hopefully it's not too bad, but there's really not much that I can do outside of just trying to save up and getting a better computer. So for the time being, I'll try to do the best I can to continue with the course, but there might be a lot of cuts in this video where I'm, between exercises and between just other stuff that we're doing on video. There's gonna be some cuts just to make it a little bit easier on VS Code, and on OBS to let it reset a little bit to regain those frames before I continue recording. But just something to keep in mind when you're watching these videos. But until I can get a better machine that's, that can eat up, that could just handle, the memory draws that VS Code has, because it's built on Chromium. That's why it uses a lot of memory. So if I can, once I get to that point, then things will be a lot easier. But for now, we'll make do with what we have. So yeah, let's start. Again, like I mentioned in the last, 2-3 videos, all the videos moving forward will encompass the entire section. So no more just reading a few headings here and content, and then doing 1 or 2 exercises, and then going to the next section, reading more, and then doing those exercises. The entire video will be just dedicated to this one section. So hopefully that just helps us speed along the course a little bit more than just dedicating 2, 3, 4 videos towards one section. Again, as before, solutions that we come up with on video will be uploaded to the GitHub repository. Links will be in the description. Go check it out and give me some feedback. I link videos in the repository to the videos I record here. But if you're watching on YouTube and you don't care about that and just want to work together here to come to solutions on these exercises that we encounter, then feel free to just continue on YouTube. All right, so more functions. So we in the previous chapter 3, we did learn a little bit briefly on functions, but this section is going to dive a little bit deeper on functions, and so we get to learn a little bit more. The learning objectives for the section are as follows. It says that you will know more about the arguments and parameters of functions. You will know how to return values from functions. This is really, really important, especially when we start writing more robust programs. Being able to write functions that return values that we can then do something with is really, 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 really important. So knowing how to do that is actually pretty crucial towards becoming a more well-rounded developer, or programmer, I should say. And how to use the values in your code. You will be able to add type hints for parameters and return values. Okay, let's quickly recap Python functions. Functions are defined with the keyword def, or shorthand for define. So this is an example of us defining a function called message. Use the def keyword, followed by the function name, followed by an open and closing parentheses, followed by the colon symbol. And then the body of our function here, again, it's indented 1 tab space to the right. So Python knows that everything following this line that's indented at least one tab space in, belongs to our function called message. So the function body here just calls the print function that's natively built into Python, and we pass this string, this message was brought to you by function. This function can be called in your program code like this. You put in the function name, followed by an opening and closing parentheses. And then your program will then print out, this message was brought to you by a function. The parameters and arguments of a function. A function can take 1 or more arguments. When the function is called, the arguments are assigned to variables, which are defined in the function definition. These variables are called parameters, and they are listed inside the parentheses after the function name. In the following code, the function greet has 1 parameter defined, while the function sum has 2. So here we have a function called greet, right? We use the define keyword. This is the function name, and this is the parameter. The parameter is name. And inside the function, right in the function body, we call the print function. We pass the string hello there, and we pass our parameter. So when we call this function, it's going to print hello there, followed by the name. here we have another function called sum. It takes in two parameters. It's defined with two parameters, a and b, and then we print the sum of the argument is, and then we do the addition of a and b. And then here we call greet Emily, right? We pass the name as a string, and then here we call sum, and we pass 2 and 3. So hello there, Emily, and the sum of the argument is 5. I think this is also revisiting what we talked about in the last section in part 3 about parameters and arguments. Formal versus actual, parameter versus argument. The terminology around data passed to functions can feel confusing. To make matters worse, some sources refer to what we have called parameters and arguments as formal and actual parameters. Other sources call them formal and actual arguments. The Python documentation specifies only the terms argument and parameter, so that is what we will use all as well. What actually happens when the function call greet Emily and we pass in the string Emily is executed. In the function definition, greet and then the parameter name behaves for all intents and purposes just like a normal variable. We can use it within the function just like we have used variables in the many main functions in our programs thus far. In the function call greet and we pass the string Emily, the argument Emily is just like any other string we have come across before. For example, we can assign it to a variable. So when the function call is executed, the value of the argument Emily is assigned to the parameter variable named. For the duration of this execution of the function, name equals Emily. When the function is called with a different argument, the value of name will be different. This terminology may all seem a bit superfluous, but computer science as a discipline does aim to be as exact as science as possible. Using well-defined terminology helps. So what does this mean? So this is, and I'll just use this window here as an example. Hopefully I haven't dropped too many frames here. I'm looking at my OBS window and it looks like I've dropped some frames. So let's say, for example, we'll define the function here, greet again, and we pass in the variable name, and then here we indent and we say print hello followed by the name. So I figured it might be easier if I use the Python playground that we've used in the past. Hopefully I don't drop any more frames. But so let's here define the function greet, define and specify our parameter will be name, and then here we print hello followed by name, like that. So when we're defining a function, what we put in between these parameters, these parentheses, when it comes to proper terminology, is called the parameter. However, when we call the function, so when we call the function greet and we pass in that value, like Emily, for example, this is called, in this instance, the terminology will be that we're passing the argument Emily into the function greet. So when we're calling the function, whatever value that we put in between these parentheses, right, is called the argument. But when we're defining a function, what we put in between these parentheses, proper terminology dictates that we call this a parameter. Furthermore, this, right, when we pass in greet Emily, Emily now takes the position or is the assigned value to our parameter in the function definition. So the parameter here is also essentially a variable that we can use throughout our function body, right? So when we pass Emily, name now becomes equal to Emily. So everywhere in our function where name shows up, when this function is called, name equals Emily, right? This is also kind of, and this might be a little confusing because in your mind you might be thinking, well, we need to pass a variable, but this is basically what happens. This is the same thing as if I was to say user name is equal to Emily, and then instead of passing Emily directly as a string here, I pass username. So now when greet is called with username, this is what we're passing in name will be equal to username inside of the function. So hopefully that makes sense. I'm still dropping frames here. There's not much that I can do. Hopefully that makes sense. If you're still having trouble understanding this, let me know in the comments below. But when we're defining a function, what we put in between the opening and closing parentheses following the function name is terminology dictates, so we call that the parameter. But when we're calling the function, terminology dictates, so we call that pass in the argument. So hopefully that makes a little bit of sense. Let's continue. Error messages when running tests. Most exercises on this course have automatic tests attached to them. If your program doesn't work as specified in the task, the test will show an error message, which may or may not be helpful. It is usually worth the trouble to read the error message carefully. In some situations, the error message might not tell you very much at all. In the next exercise below, you may come across this error message. So when we hit this I button up here, this is how we run our tests now and forever, basically to the end of the course. You click on this button, it run the test. This was the same thing as hitting the run tests button on the embedded editor in previous exercises that we've done on the course. But now we do it from hitting this run tests button at the top after we install this TMC extension. So here, this exercise, the test failed, and it tells here the failure is line test to function can be called with empty string. Calling a function as follows should work. And then here, so whatever solution that wasn't inputted into this exercise, right, they didn't account for being able to call the function line, pass in this first argument. So line takes in two arguments. It takes in an integer and it takes in a string that you can also pass it with an empty string, and the function should work. So this function, when called, and this solution from this image, they didn't account for, or they didn't properly write the code that would allow this function line to run with an empty string. So the message just says that you should be able to call the function line with specified arguments, an integer 5 and an empty string. The actual issue becomes clear when we try executing the function call specified in the error message. You can do this by copying the function call into your program and clicking on the triangle. So here, if name is equal to, right, this is the if block that's defined already for us in the exercise file here. Called line, passing an empty string. When they run that function, and then down here is the error being printed again, right? Index out of range, because the code didn't take into account calling the function with a empty string on the second argument. The last lines produced by the execution highlighted in the above image tells us that line 4 of our code causes the error string index out of range. In the previous part, there was a similar example where we tried to use an index that fell outside the scope of the string. This time the error appears because we're trying to access the first character of an empty string, that is a string of length 0. Okay. This will make sense once we start actually doing the exercise, which the instructions for it are down here. So this exercise is called line. It says please write a function named line, which takes two arguments, an integer and a string. The function prints out a line of text, the length of which is specified by the first argument. The character used to draw the line should be the first character in the second argument. If the second argument is an empty string, the line should consist of stars, an example of expected behavior. So here we call line. We pass in the first argument, an integer, 7, and the second argument is a string. It's a string that is the percent symbol. We call line again. We pass in 10. We pass in LOL, and then we pass in line and an empty string. So when we pass line, when we pass this argument 7 and percentage, it just prints 7 percentage symbols. When we pass in 10 and LOL, it prints L 10 times. Now, why is it not printing LOL? Again, if you remember in the exercise instructions, it says the function prints out a line of text, the length of which is specified by the first argument, so that integer. The character used to draw the line should be the first character in the second argument. So we can type in whatever we want in the second argument here. It could be a long, long string. All we care about using is the first character in that string. So that's why it's printing only LLL 10 times. And then here we call line with a length of 3, in an empty string, and it defaults to using the asterisk symbol. Okay, so write our solution. We're going to write it up here. Define our function called line. It takes in the first argument, we're just going to call it length. And then the second argument is just going to be a string. And here we're going to print the string times the length. So let's just test it for now, right? This has already been written for us, so we don't need to worry about this if block to make sure that we're in the main block here to run our function. So I'm just going to hit the run button here at the top. Okay, and it runs and it prints 5 x's. Cool. Let's call this again, and let's write like hello world as one string like that, and let's see what happens. It prints hello world 5 times. Remember, we only need to print the first character. So what we need to do here is just string indexing, get the first character from string, and then print it however many times the length is. So when I run this again, now it prints HHH 5 times. Awesome. Okay. We also need to remember that when we pass an empty string, then it should default to just asterisks, right? So if I was to copy this again and pass it with an empty string with our code currently as it is and run it, we're going to get that same error, index out of range, right? Because we passed in an empty string, right? We can't access an index of an empty string. So what we're going to do here is just say if string does not equal an empty string, then we want to print that first character from a string. Else, we want to print asterisk times the length, like that. So now let's run this again. And now as you can see, it prints 5 asterisks when we pass in an empty string. We can also, just to be safe, which is what we always like to do in our videos, is copy the inputs that is provided in the exercise description, paste it into our code, and run it, and see if we get the same outputs as what's expected of us over here. So let's run that. Oh, it's not running. There we go. And there we go. We get 7 percentage symbols, we get 10 L's, and we get 3 asterisks. So this should be a passing solution. So let's run our code. Let's test our code and see what happens. And there we go. We passed all tests that are prepared for us for this exercise. We're going to send the solution to the server so we can get credit for it. And there we go. As you can see, the green dot popped up over here, indicating that we've gotten credit for this exercise. And we can go ahead and close this tab here. And we can go ahead and also close this line, this file, collapse this folder, and go ahead and open the next exercise, exercise 3, box of ashes. And let's continue reading the instruction. Actually, in fact, if I hit the refresh button here, we should see that we got credit for it. So there we go. Congratulations. Again, if you didn't watch the previous video at the end where we take on the Hello World exercise, Hello Visual Studio Code exercise over here, that's where we were also able to make sure to double check that we got credit for the exercise by hitting that little refresh button. And when the exercise box turns green and you get 1 out of 1 points, that means you got credit for the exercise. All right, function calls within function calls. You can call a function from within another function. In fact, we have done so many times before when we call the print function within our own functions in the previous part. Our own functions are functionally no different. In the following example, the function greet many times calls the function greet as many times as specified by the argument times. So here, remember the function that we talked about at the beginning of this section when we're reading the course material, right? We define this function called greet. The parameter for this function is it's called name, and then in the body of the function we print hello there, and we pass that name to the print function. Now here we define another function called greet many times, which takes in a name and takes in the number of times we're going to call the function greet. So while times is great, and then here in the body of the function we have a while loop, which has this condition: while times is greater than 0, call the greet function, passing that name, decrement times by 1, so we can eventually get to a point where we get to exit out of this while loop and also exit out of the function. So now when we call greet many times, we pass in that name Emily and 3. It prints hello there, Emily 3 times, right? And essentially what it's doing is it's passing Emily to the greet function, and then this 3 is passed into the times parameter, or as passed as an argument to the, which is going to fulfill this times parameter, and that's how many times we're going to run this function. All right. So hopefully that made sense. If you're having trouble with this part of calling functions inside functions, let me know in the comments below, and I'll try to make another video covering that a little bit more in depth. This exercise is called a box of hashes, and we're told to please write a function named box of hashes, which prints out a rectangle of hash characters. The function takes one argument, which specifies the height of the rectangle. The rectangle should be 10 characters wide. The function should call the function line from the exercise above for the actual printing out. Copy your solution to that exercise above the code for this exercise. Please don't change anything in your line function. Some examples of how the function should work. Here we call box of hashes with 5, and it prints out 10 hashes 5 times in 5 lines. Same thing here, when we call box of hashes, we pass in 2, it prints 10 hashes per line twice. So it tells us that we need to copy the solution. So we're going to copy that, come over here, paste it. So now when we call line, it should print out 10 times or whatever. Well, I mean, we pass in box of hashes with the height, it should print out this, it should call this function line, and with 10 hashes per line. But we need to tell it to print however many times the height is. So what we do is use a while loop. So we'll say while height is greater than 0, then we want to call line 10 times, and then we want to say height is equal to height minus 1, so we can decrement height. So let's run this and see what happens. Okay, and there we go. We get 1, 2, 3, 4, 5 lines, right? And each line is 10 hashes wide. Now we can also, for the sake of testing, call box of hashes one more time and pass 2 as the argument just to see it, if it's going to print 2 lines. And there it is. It prints 2 more lines. Okay, so let's test this, see how we do. And there we go. We passed all our tests. Send solution to the server so we can get credit for this exercise. Go back to the browser, refresh, and boom, we got our credit for submitting that exercise. All right. Okay, we have another exercise here called a square of hashes. It says please write a function named square of hashes, which draws a square of hash characters. The function takes one argument, which determines the length of the side of the square. The function is called the line function from the exercise above for the actual printing out. Copy your solution to that exercise above the code for this exercise. Please don't change anything in the line function. So we're going to be reusing this, so I'm going to copy it, close that, collapse those folders. So here we're going to paste our line function. And then, so we already have the size, we already have square of hashes partly defined for us. So we need to call this as many times as the size. So if I'm not mistaken, we need to pass size to the line function while also using a loop. So I'm going to declare a variable here called index, set that equal to 0. And then I'm going to do, while index is less than size, call line, pass in the size, and then decrement index by 1. So now when we run this, okay, we're getting an, I'm so sorry. Well, index is less than size. Index is greater than, no, this should be right? Well, index is less than size. No, what? Wow, I'm confusing myself here for a second. Wow, I don't know why I was confusing myself here. It's +1, not -1. I had to take a second because I was just getting some brain fog for a second. But it's +1, not -1, right? Because index is less than size, and we want to get up to the index as close to the value of size, right, without going over it. So we increment index by 1, and that should, when you run your function, should print out 5 hashes in 5 lines. So 1, 2, 3, 4, 5 lines, and then each line has 5 hashes. And again, just to be safe, to make sure that our code is doing what we want it to do, we're just going to call square of hashes here and pass in 3. Run this, and there we go. We get 5 hashes, 5 lines here with 5 hashes per line, and we get 3 hashes per line in 3 lines. Okay, so let's test this. And there we go, our test's passed. Send the solution to the server. There we go. Refresh the exercise in the browser, and we get credit for it. Okay, here we have another exercise called a square. It says, please write a function named square, which prints out a square of characters and takes 2 arguments. The first parameter specifies the length of the side of the square. The second parameter specifies the character used to draw the square. The function should call the function line from the exercise above for the actual printing out. Copy your solution to that exercise above the code for this exercise. Please don't change anything in the line function. Okay, so I'm just going to close this. Make sure I copy that. Close that as well. Open this exercise. Paste our line function here at the top. Okay, so when we call square, we pass 5 and we pass in asterisk. It prints in 5 lines. Each line contains 5 asterisks. When we pass in this little circle, it prints that out 3 times as well. So I think this is pretty similar to what we just defined here. So instead of line here, we pass character. And then here we're going to declare index is equal to 0, while index is less than size. Call line, pass in the size, and then increment index by 1. Let's run this. And there we go. We get 5 asterisks, and we get 5 lines printed. If we copy this and paste it here, just to make sure we get the same solutions, same expected outputs, and yes, we do, which means our code is running as it should. Let's run our tests. And there we go. Send the solution to the server so we can get credit for our exercise solution. Reset our exercise on the browser, and we got credit for it. Okay, this exercise is called a triangle, and we're told to please write a function named triangle, which draws a triangle of hashes and takes 1 argument. The triangle should be as tall and as wide as the value of the argument. The function should call the function line from the exercise above for the actual printing out. Copy your solution to that exercise above the code for this exercise. Please don't change anything in the line function. So some examples here. When we call the triangle function, we pass in 6. It prints in this triangle here, this right angle triangle. Right, it's 6 lines tall, and it goes at its widest point. It's also 6 hashes or 6 characters wide. Same thing here. When we call a triangle, we pass in 3. Prints a triangle that's 3 lines tall, and at its widest point, it is 3 characters wide. Okay, so we know we're going to need this align function again. So I'm going to copy that, close this folder, open our triangle source file here, paste the line function here. And so when we call line, so this one should be pretty simple. We're going to have a variable here called index, set that equal to 0. Actually, no, set that equal to size. And then what we're going to do is call line, pass in the size, and then we're going to decrement index by 1. In fact, actually, no, we don't even need to declare another variable here. We could just use the size variable. So while size is greater than 0, pass size and then decrement size by 1. So let's run this. And there we go. But we get an upside down triangle, so we need to go the other way around. So we need to use an external variable, which says declare a variable called index. We say while index is less than size, pass size, actually no, pass index for size, and then increment index by 1. I think this should give us the triangle that goes up. There we go, but we're missing one character at the top here. So we'll set that equal to 1. Set this less than or equal to. And there we go. We get 1, 2, 3, 4, 5. So let's do it this way. And run it. There we go. We get here a triangle that's at its widest point, it's 6 characters wide and it's 6 lines tall. Here we get a triangle that is at its widest point, at its base is 3 characters wide and it's also 3 characters tall. So let's run this against some tests. And our solutions passed all tests. Send this solution to the server. We passed. We can refresh our exercise on the browser and we get credit for that one. So I just skimmed ahead a little bit here. We already see that we're gonna need the line function. So I'm just gonna go ahead and copy it here, close that exercise, open the shape folder, and we're going to paste our line function at the top here. Now let's read the instructions. It says, please write a function and name shape, which takes 4 arguments. The first 2 parameters specify a triangle as above and the character used to draw it. The first parameter also specifies the width of the rectangle, while the third parameter specifies its height. The fourth parameter specifies the filler character of the rectangle. The function prints first the triangle and then the rectangle below it. The function should call the function line from the exercise above for the actual printing out. Copy your solution to that exercise above the code for this exercise. Please don't change anything in the line function. Okay, so this one's a little bit busy. So when we call a shape, we pass in 5. The character that we want to use to print it, this will be the use for this, and then this will be the character used to print that. So what I'm assuming is inside the shape function, we're going to be calling line twice. First time will be to do the triangle print, and the second time will be to do the rectangle print. Don't try and solve this exercise all at once. A good first step will be to make sure you can print the triangle reliably. Then you can try adding the rectangle. This is one of the most important skills of a programmer. Concentrate on small, tangible sections of the problem at a time. This is a good a hint here. Solve and verify partial solutions and use them to build towards a complete solution. So again, just in my mind here as I'm thinking, I know that we're going to be calling the line function twice because we've already used it to print rectangles and we've already used it to print triangles. So let's first define the function shape. We know it's going to take in the first argument, which is the width of the triangle. So first will be width, which will also define the height as well. Then the character, followed by height, followed by, I'm just going to use a symbol. So we're going to have a variable here called index, set that equal to to 0. Then we're going to do a while index is, I should set that equal to 1. While index is less than or equal to width, call line, pass in the width, and pass in the character. Then index is equal to index plus 1. Okay. And then just for the sake of avoiding errors, I'm just going to print height, and I'm going to print symbol. So let's run this and see if we just get the triangle first. Okay, we're not getting a triangle. How do we solve this exercise here? Index is equal to 1, while less than equal to size. When we called line here, we pass in and then we pass in the character, right? Oh, we pass in index. So we pass in index, not width. Okay, so let's run that. Okay, now we get our triangle here, which is great. So now we can focus on printing the rectangle. So now we're gonna say, well, no, I'm gonna print. Just set this equal to 0, j, and then while j is less than height. In fact, actually, I don't think we need j is less than height. Call line, pass height, and then pass symbol. Then j is equal to j plus 1. So let's see if this is going to print the rectangle right beneath it. Okay, it does, but it prints in, doesn't print in these symbols that many times. I mean, the width isn't the same as the one for the symbols. So let's just scroll up here and remember for a square what we did. So we also incremented by 1, which what we did here. I think box of hashes might be a better one to look at. Height is greater than 0. We call a line here, so maybe we should do this way. While height is greater than 0, pass line of height and then decrement height by 1. So maybe we don't even need to use j here. Let's run this. Whoops, sorry, I meant to keep this open. While height is greater than 0, call line, pass the height, pass the symbol, and then decrement height by 1. But why is it printing this inverse triangle? J is less than height. J is equal to j plus 1. Okay, so the issue with the second loop was that we were using height for both as also the parameter for passing width. So width we know because the width at the widest point, right, the base of the triangle, is going to be as wide as the width of the rectangle that we print beneath it. So we needed to pass width to the line function here, but use the height as the way to limit the height of the triangle that we print. So here, instead of passing height as well, or instead of passing j, pass width so that we can print that rectangle as many times as wide as the widest point of our triangle. Hopefully that made sense. I had to take a second to think about that off screen. So now when we run this, right, with these inputs, I'm just gonna copy them. We should probably see all the right outputs. So there we go. First, we get a triangle here that is 5 characters tall, and at its widest point is 5 characters wide. And then we also get a rectangle that's 3 lines tall, and it's as wide as our triangle is. Same here, which is what we see here. Same with this instance, we get a triangle that's 3 lines tall. I mean, two lines tall, and it's 2 lines wide, and then a rectangle that's 2 lines wide and 4 lines tall. And then same down here, we get these dots with a triangle, and then the empty commas. Because we pass in 0, so it doesn't print in a triangle. It just prints in just the triangle itself here. Okay, so I think that should be the solution for this. If you have trouble with this exercise, let me know. Again, it's a little it was a little tricky just to remember that it was such a. That's why I even put this comment here, because when I know when I upload these solutions to GitHub, it's gonna make sense when you see this comment. That's what we're passing with here. Pass width as the argument for line, not height or any other variable. And just for the sake of clarity, I'm just going to change index here from fully spelling out index just to I, so we can have I and J being used in the function. So let's test this, see how we do. Pass all tests, send the solution to the server. We got any credit for that. Refresh, and there we go. Okay, here we have a function, an exercise. I think that's 1, 2, 3, 4. Okay, we have 4 exercises left. Hopefully we can get these done in the next hours. Not hour, but within the hour. Okay, here we have an exercise called spruce. It says, please write a function named spruce, which takes 1 argument. The function prints out the text a spruce and a spruce tree, the size of which is specified by the argument. Calling spruce 3 should print out a spruce, and then we print out a triangle with 1 asterisk at the bottom. Same thing here, 1, 2, 3, 4, 5. We print out a triangle with 1 asterisk at the bottom. To the left of the spruce, there should be exactly the right amount of white space. If the shape of the spruce looks correct, but the left edge of the tree is not touching the left edge of the text area in the terminal, the tests will not accept the solution. Okay, so we're told we don't need to use the line function here, so we're not going to use it. I need to open the sidebar here again. I'm going to collapse these folders. Open spruce. So we need to define a function called spruce, which takes in a size. We're just gonna start simple here and print out a spruce. So when we run this, it should just print out a spruce. Okay, there we go. Okay, so we print spruce, right? And now we need to print the tree. So we're gonna use a loop. Have we learned for loops yet in this course? I don't think we have. Maybe we did when we were using strings, but we'll use while loops. While I is less than or equal to the size. So what we need to know is that each pass of the loop creates 1 level of the tree. So when the loop runs the first time, it creates the first level. When it runs the second time, it runs the second level. When it runs the third time, it runs here when we call it spruce and pass 3 as the argument. Right? Third time we pass the loop, we print out the next level of the tree, and then this is for sure going to have to be done outside of the loop, right? Because every spruce tree has a trunk, so we can always print out the trunk. Okay, so but as you can see that each line here has a space, right? The first line has the most amount of spaces, the second line has a little bit less, third line has a little bit less than that, and then the final line has no spaces at all. So we need to calculate, or we need to be able to center the amount of stars that we print uh, per how do I say this? Per line, right? Granted, how many spaces we're gonna need to print. So we're gonna have a variable called spaces, and we're gonna set that to an open string. An empty string times size minus I, not minus one, minus I. Right. So that's how many spaces we have. We want as per line to have as many spaces minus the amount of characters that we're going to be printing per line. So the I here is going to be the amount of characters that we're going to be printing per line. So on the first line here, we have only one character, right? In a spruce tree that's 5 characters tall, 5 lines tall, we're going to print one character, and then we're going to need as many spaces left and right as there are going to be characters next to it. So here in the final line, we have how many? 4, 5. We have 9 characters, and then this one asterisk right dead in the middle. So we need as many spaces to the left as there will be to fill this line up, and as many to the right as it's going to fill up this side of the line. So that's what we're doing, size minus I. Right? If the tree has one row, right, the first row gets, if a tree is 5 lines tall, hopefully this makes a little bit more sense, then first row gets 4 spaces, second row gets 3 spaces, third row gets 2 spaces, and so on and so on and so on. So hopefully that makes sense. Even here, right, first line gets how many? Gets 5 spaces. Second line gets 3 spaces or 2 spaces, and then so on until we have no spaces to print, so we can print out the full tree. So that's why we're doing size minus I here with the amount of empty spaces. Okay, so now we need to print the stars. We're going to have a variable here called stars, set that equal to the asterisk that we're going to use times 2 times I minus 1. Okay, now why are we doing this? Right, now we know that each row, we can visually, if we look at this, we can see that each row gets an odd number of stars. Right, the first line gets 1 star, the second line gets 3 stars, and then the final line here gets 5 stars. So how can we always make sure that we get, and with each line, we I don't want to say we double, but each line basically doubles minus 1. You get what I'm saying? I don't know if that makes any sense. Let me take a second to think about this so I can prepare what I want to say so it sounds a lot clearer. Okay, so think about it this way, right? We're always going to have a center star per row. And with each row, the amount of stars that we print will be 2 more than the previous row in order for us to create this little diamond shape. So we know that each time it's going to be odd, right? If we start at 1 with 1 star, and the next row is going to have 2 times, not double, it's going to have 2 more stars in the previous row to make that little diamond shape. Because again, we're always going to have this centered star. And then same thing here, right? We have this middle star, and then now we're going to have 2 more stars in this line than the previous row. The previous row had 3 stars, so now we're going to have, imagine if these were the original 3 stars from row 2, but then we add these 2 more outer stars to continue making this little diamond shape. So that's why we do 2 times I minus 1. Now you could do 2 times I plus 1. All right, because we haven't gotten to the next step, but we actually, I'm getting ahead of myself. We gotta print these the spaces and stars. So let's just quickly do that. Spaces plus stars, and then we need to increment index by 1. So we just do that. That way, so we can be able to exit this loop. So let's run this. All right, if we do plus 1, we're going to be index out of bound. There we go. So now we have
our little diamond plus here. If you start at 0, then we can do +1. There we go, and it still works. But as you can see, again, it's still odd numbers, right? Odd numbers. 1 is odd, 3 is odd, 5 is odd, 7 is odd. So if you start counting at 0, then here you can do +1. If you start counting at 1, but we need to, because if we pass, but the only issue is if you start at 0 and you do +1, it's going to print one more row than you need. So that's why we start at 1 and we do -1 here. So we don't exceed the number of lines that we need to print. Okay, so there we go. We print a spruce, we print the top of the spruce tree, and then what we need to do now is print the base of the tree. So outside of the loop, but inside the body of the function, we're going to print the base or the trunk, which is going to be an empty space multiplied by size -1 plus our single asterisk, like that. I'll put a space there. And there we go. That prints out the base of our tree. And so if we call spruce one more time here, we pass 5 with this larger tree, right? So we get the same tree printed out here. So this was one of those exercises where I didn't take a second to think about it before doing it. That's why I had to pause in the middle of it just to go on Python Playground and play around with it a little bit just to have a clearer picture in my brain. But this is how we print. And I'm pretty sure, I was trying to remember this, but I didn't want to take too long with this video. But I'm pretty sure we did do an exercise either in part 1 or part 2 when we were learning about loops. And one of the earlier exercises when we were learning about loops, we did print a spruce tree or something similar. I think it was a Christmas tree or something like that. Go back and see. I'll go back off camera and off the video and see. But if I remember, and if we do, I'll put that in the description below so you can use that as a starting point. But I'm pretty sure we did an exercise where we used, where we were told to use a loop to build something very similar to this. So yeah. Anyways, that should be the solution. Let's run our tests here and see how we do. We pass, send that solution to the server, and there we go. Refresh, and we got credit for that one. Okay, so we have here some readings, and then we should have 3 exercises left to do. All right, so let's get through this. We're almost at the end of the section. I think this is probably one of the longest sections that we've had so far. So yeah, this video should definitely spill over well over the 1 hour mark. All right, the return value of a function. Functions can also return values. For instance, the built-in Python function input returns an input string typed in by the user. The value returned by a function can be stored in a variable. So here, we've done this hundreds of times now in the previous exercises in part 3, in part 2, in part 1, where we take in an input from a user, right? So when we do that, we're calling the input function, right? This is just going to be what we're prompting the user to type in, but but Python is going to capture that input from the user, and then we're going to take that captured input and assign it to that variable word. When you want an integer value from the user, the input from the user has to be converted into an integer. The function we've used for this purpose is int, and it returns a value, right? So we've done this a couple of times in the past, right? We prompt the user for an input, but we want that input to be converted into an integer, so we wrap the input function in the integer function. So that's going to capture the input from the user and convert it into an integer type. The function int takes in the string returned by the input as its argument, right? So input returns a string, and then we pass that string to the integer function, and that's going to cast that string into an integer value. So that's what this is saying here. Okay, the return statement. The function you define yourself can also return values. To do this, you need the return statement. For example, the following function, mySum, returns the sum of its parameters. So here we define a function called mySum. It has 2 parameters, a and b, and in the function body, we return a plus b. So then we can assign the return value to a variable called result. So we can say result is equal to, then we call that mySum function we pass in 2 and 3. Now result is going to be whatever the return value of 2 plus 3 is. And when we print sum, right, result is going to be 5, right, because 2 plus 3 is 5. Here's another example of a return value. This function asks for the user's name and returns the string user types in. So we define a function here called ask for name. Inside of that function, we have a variable called name, which stores in the captured input from the user. Right? We prompt the user for their name. The user types in their name. We save that string to the variable name, and then we return name. So here we have a variable outside of this function. Remember, scoping in programming, but in Python in particular, variables defined inside functions exist inside the function only. And then, so that why we can also, that's why we're able to use name outside of the function as well, even though we use the name in here as inside the function as well. So here we have name, we call that ask for name function, and then we print whatever is returned from ask for name, we assign it to the name variable, and then we print it out here. So here, when we call, it says what is your name, and then we print in, what is your name? We print it, we type in Anna, and then here we print out hello Anna. The return statement ends the execution of the function immediately. The following is a nifty way to create a comparison function. Here we define a variable called, a function called smallest with 2 parameters A and B. Here we say if A is less than B, return A, otherwise return B. Then here we print smallest, we call smallest between 3 and 7, right? So it's gonna pass 3 and 7 to smallest, right? If 3 is less than 7, return 3, otherwise return 7. That's basically what it's doing when we call smallest and pass 3 and 7. Same thing here, we call smallest, we pass 5 and 2. It's gonna check if 5 is less than 2, return 5, otherwise return 2. 5 is not less than 2, so it's not gonna kick this, it's not gonna execute this, it's going to execute this. It's going to return 2. The idea here is that if A is smaller than B, the function returns A and exits immediately. If not, the execution continues to the next line where the value B is returned. This is, if you remember, especially in this example, if you remember when we were using if statements with within loops, or if within loops, so we can do, hey, if this value equals to this, or if this value is smaller than this value, then exit, right? Otherwise, do something else. So this is almost like doing the exit, using exit to break out of a loop. The return keyword or the return statement automatically kicks you out of your function and then also attaches whatever value that we want to return out of this function. If not, the execution continues to the next line where the value B is returned. A function can never execute 2 separate return statements with a single function call. So here it returns 3 and here it returns 2. You can make use of the return statement even if the function doesn't return a value. Its purpose then is just to end the execution of the function. So here we define a function called greet with a parameter name. If name is an empty string, print out 3 question marks and then return, right? Basically, do this and then kick us out of the function. Otherwise, print hello there. So if name is not an empty string, then print the name. Print hello there followed by the name. So here when we call greet and we pass in Emily, it's going to print hello there Emily. If we call greet and pass in an empty string, it's going to print out the 3 question marks. If we pass Mark as the argument for greet, it says hello there Mark. Right? If the argument which gets stored in the variable name is an empty string, the function prints out the 3 question marks and exits. Using return values from functions. We already know that the return values of functions can be stored in variables, right? We've seen this example before, right? So result stores the return value from the mySum function. So mySum does 4 plus 6, and then the result is stored into the variable result. So 10 will be stored into result. The return value of a function is a value just like any other. It is not necessary to store it in a variable in order to give it as an argument to the print command. Right, so we can do this in line, right? We don't have to, this is just an extra step. We can skip this step entirely and pass mySum with its 2 arguments directly into the print function, which is what is being done over here. So we can just do the sum is, and then call my sum and pass in these two arguments, and then it's like doing the same thing as doing this. The return value of a function can become the argument of another function, right? Which is again what we're doing here. We're passing my sum as an argument, as a second argument to the print function. So here we define a function called my sum with two parameters, a and b, and we return the sum of a plus b. Here we define another function called difference, and takes in two parameters, a and b, and we return the difference of a and b, right? A minus b. So here the result is equal to, we call difference, we pass in my sum 5 and 2, and also my sum 2 and 3. So what it's going to do is call difference with the return value from doing this and return value from doing this. And another way of saying this, call difference, and here pass in whatever 5 plus 2 is, which is 7. So difference, first argument is 7, and the different second argument is 5. So it's going to be difference, 7, and 5, and it's going to return 2, right? So here the result is 2. So this is what it's doing. We can pass functions into other functions that take in parameters or take in arguments, right? When we're calling a function, it's calling whatever value we pass into the parentheses is the argument. When we're defining a function, whatever we define between the parentheses is called the parameter. In this case, the inner function calls my sum with 5 and 2 and my sum with 2 and 3 are executed first. The value they return, 7 and 5, are used as the arguments of the outer function call, the difference function. The outer function called difference passes in 7 and 5, returns the value 2, which is stored in the variable result, and then printed out. In summary, values returned by functions work exactly like any other value in Python. They can be printed out, stored in variables, used in expressions, and used as arguments in other function calls. Okay, the difference between return and print. Sometimes the difference between a function returning a value and a print statement within a function can be confusing. Let's have a look at two different ways of implementing a function for working out which of two values is greater. Here we define a value, Here we define a function called max1, takes in with two parameters, a and b. Then we have an if statement inside. It says if a is greater than b, return a, otherwise return b. Here we define a function called max2, which also has two parameters, a and b. But here we say if a is greater than b, print a, otherwise print b. Result is max1, 3 and 5, right? We pass in 3 and 5, and then we print result. And down here we call max2 when we pass in 7 and 2. So when we call, for this instance, first it prints out 5, and in this instance it prints out 7. Both versions seem to be working just fine as the maximum values are printed correctly. There is a fundamental difference between the two, however. The first of the two functions, max1, does not print out anything on its own, but instead returns the value which is greater. If we execute the following line, max1, when we pass in 3 and 5, nothing seems to happen. The return value of the function has to be used in some way in the code which called the function. For instance, it can be stored in a variable and printed out, like this. So whatever is returned here is stored in the variable result, and then we print result. And if also you remember, we can also just pass the function call directly into the print function. The second version, max2, uses the print command within the function to print out the greater value. If we want to see the value, it is enough to call the function. And the greater value, so we can call max2, pass in 7 and 5, and the greater value is printed out. The downside of this handy function is that the value worked out by the function is not available for use in the program which called it. That is why functions which return values are often the better option. So we can't do much here, right? Outside of just printing out the value. We can't store this value anywhere. But I am curious to see if we can call it inside the print function. So let's do that. So again, this should just print result, which should print 5, right? Because 5 is the greater number, and which is what we're doing here. And then here it's printing 7. But what happens if we do print max 2, and then we pass in 7 and 2? Is it going to do a double print? Okay, so it does print 7 again, and then it also prints none. Interesting. So you can do that, but it's gonna return this none thing. I'll have to look this up. I've never. This is just curiosity here. I'm just playing around. But this is some of the stuff as a programmer. Once you get more comfortable, you're gonna start asking yourself these kinds of questions, like, hey, what happens if I do this? What happens if I do that? Right? How is Python going to react to those scenarios? So that's what happens. So we can technically call this. In fact, I'm just gonna look this up. Why is it returning none here? Okay, so a quick Google search later. None is automatically returned when functions that don't return anything are called in a position where there's kind of like how do I explain this? When you call a function that doesn't return anything, for example, like in the print statement, it's going to return none, right? It's basically saying, hey, this function doesn't return anything. So it automatically returns none. Even though it prints out 7, 7 isn't a return statement because we're still here calling the function. And the function is still executing and is still going to print out 7 as the larger of the two values of 7 and 2. But the function itself doesn't return anything. So Python is going to automatically print that out, this none, indicating that this function being called doesn't return anything, right? It returns none. Hopefully that makes sense. So this is an intrinsic thing, right? It's an intrinsic thing that is embedded in, that is built into Python when functions are defined that don't return anything. And those functions are called in a position where they're supposed to return something, but they don't. So it's just basically saying, hey, print, what we're doing here is basically, right, we're calling the function, it's going to do whatever it's going to do inside of it, and then the print function is expecting this function to print something, to return something, right, when we're calling it in this nature. But it doesn't, right? But naturally, built into Python, the return type is none. So what the print statement is doing is printing none. Hopefully that makes sense. But again, this is one of those moments where we're just playing around and thinking about stuff and getting curiosity. Getting curious about stuff. But that's what happens. That's why we're printing none here. Well, why none is being printed, not that we're printing none out. Okay, let's continue. We have 3 exercises here to do. It says here, please write a function named greatest number, which takes 3 arguments. The function returns the greatest in value of the 3. An example of how the function is used. Okay, so we can close this. Open the source code here. We're going to define a function called greatest number. Takes an A, B, and C. Okay, and then, so we just have a conditional here. If A is greater than B and A is greater than C, return A. Else if B is greater than A and B is greater than C, return B. Else, return C. Okay, so if we run this, we should get 8. Okay, here we get 8. Let's just copy these. So we should say 499 and 0. Yep, 499 and 0. So let's test this. Test failed. Greatest number should not return 1. Now it returns negative 100. Okay, so let's do that. Why did it fail? With what numbers? Just gonna pass those to my function. Let's run this. Okay, so we need to also consider negative numbers. Okay, I think because right, so it failed with this test, right? With 1, 1, negative 1. So let's walk ourselves through this. We plug in 1, 1, and negative 1. So here it checks if 1 is greater than 1, and 1 is greater than negative 100, return 1, right? But 1 is equal to 1, so this is going to return false, while this side returns true. So it's going to bypass this. Same thing here, it's going to check 1 is greater than 1, and 1 is greater than negative 100, right? 1 is equal to 1, so this is false. And remember, in Python with operators, using the AND operator, both sides of the operator have to be true. So even if one side results to false, then this whole thing returns false. So that's why it doesn't kick this. It goes here and just returns negative 100. Right here it works. I mean, my original statement when I said we have to work with negative numbers, right? Here we have a negative number, negative 4. But 99 is clearly greater than negative 4, and it's also clearly larger than 7. That's why we return 99 correctly. I think if we do greater than or equal to, it should work correctly. Okay, so now here we have 4, 99, 0, and 1. Let's run our tests. And there we go. Send solution to the server. Refresh. There we go. We got credit for that one. Here we have another exercise called same characters. It says please write a function named same cars for same characters, which takes one string and two integers as arguments. The integer refer to indexes within the string. The function should return true if the two characters at the indexes specified are the same. Otherwise, and especially if either of the indexes falls outside of the scope of the string, the function returns false. Some examples of how the function is used. So here we call same characters, programmer 6 and 7. So 0, 1, 2, 3, 4, 5, 6. So 6 and 7 is M and M. That's true. Here, same programmers 0 and 4. 0 is P. 1, 2, 3, 4 is R. So this is false. And here 0 and 12. This is not within range, so it returns false as well. Okay, so open the file. Oh wait, I need to close all of these so it doesn't open another tab. Same characters like that. So we need to define a function here called same characters. Takes in a string and it takes in two indexes. I'm just going to use A and B. And so what's the test cases here? It says if the indexes are inbounds, then check them to see that they return. If they're the same, if they are, return true. Otherwise, return false. And then, otherwise, especially if the indexes fall outside of the scope of the string, the function returns false. Okay, so I think what we should first check is whether or not the indexes are out of bounds to the left of the string. So if A is less than 0 or B is less than 0, then return false. That means the index is going to be out of bounds to the left of the string, right? Because our indexes are at 0 for every string. So if we have like a -1 or -2, -3, or whatever for either A or B, then we automatically return false because either one of these is going to be out of bounds. Okay, and then if A is out of bounds to the right of the string, the same thing for B, then we need to also return false. So if we get, for example, here, 0, 1, 2, right here we have index 12, but if this string is not doesn't have an index 12, then we need to also return false. So just check if either one of them is false and return false. Okay, and then finally, if string at A is equal to string at B, then return true. Like that. So check if the index of the given string at position A is equal to that string at position B, then return true. I think it should be the way to go. Just gonna copy these test cases here, print them down here, indent, run our program. Okay, we get true, we get none, and we get false. Maybe if we do just return the evaluation. Okay, so that's okay. So we don't need to do an if statement here. Just do return string A is equal to string B, right? Just return the evaluation of this. If it's true, then just return true. So here, for 6 and 7, it's these two M's, returns true. For P and what is it, 0, 1, 2, 3, 4, for P and R, right? Not the same, it returns false. And here we have an index string out of bounds, index out of bounds, and it also returns false. So we get these three. So when we run this, tests pass, send our solution to the server, refresh, we get our credit. And now we have our final exercise of the course. This is, I mean, not the course, of this section. This video is pretty long, an hour and almost an hour and a half. So hopefully we can muster through this and wrap this up. So let's open the exercise folder. Close this so it doesn't open another tab. So we need to define 3 functions: first word, second word, and last word. Each function takes a string argument. Again, as the names imply, the first function returns the first word. So we haven't learned this yet, but which I'm surprised that they didn't cover this when we were learning, diving a little bit more. When we were learning more about strings in the previous chapter, in chapter 3, there is a section working with strings where we learn the .find function that is available with strings, the how to slice strings, right, and get substrings from sentences and whatnot. Surprised I didn't cover this, but this is there is a built-in string function that allows you to split strings by certain finders, right? Certain tokens. So I'll show you what I mean in a second. So define first word, takes in a sentence, and in here what we're going to do is just return sentence dot split, and then like that. So the dot split method that exists for all string objects in Python will split a string based on a given token. Here we're passing an empty space because we want to split our sentences by spaces, and it's going to return that string now. So our string is going to be, it's going to return a list basically. It's going to convert our string into a list and then return that. And then from there, we can access the first item of the list using square brackets. So it's going to take, it was a dark string in Python, right? Get rid of the space, break this up into by the spaces. So it's going to be so it's going to be a list, right? We know how lists look in Python. It's going to be like this, 1, 2, 3, 4, like that. But instead of that, it's going to do this. It was a, and then dot, 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 right, to the rest of the string. So using these square brackets, we can tell Python, hey, whatever list it returns, give us that first item, right? So that's how it's going to return it in this, for example, here in this string here, once upon a time, there was a programmer, it's going to return once. Okay, now how do we do the second word? Same thing, just define second word, sentence, return sentence dot split by that, and then we can pass in 1. So that's going to be the second item in the list that's returned. And then for the last word, define last word, pass in the sentence, and then we're going to return sentence dot split split by spaces, and then pass in -1 to grab the last index. So this we know it should return once, this we know it should return upon, and this we know it should return programmer. So let's test this and see if it works. And there we go, once upon programmer. And that's it. This is pretty simple, but but they didn't teach us this. And I'm going to revisit this exercise again in a separate video because there is a way we can also do this using the find. Again, I have this opened up here. Where is it? We learned this in this chapter, in this subsection. Right? This one we were learning how to slice strings and get substrings. Let's just find. Here it is. So this section walks you through how to find specific substrings inside of a given string. So you can use this .find and then pass in an empty string, a space, and it will locate the first space in your given string. So I will make another video, walk you guys how to solve this exercise using .find instead of using the split method. But the split method is so straightforward. I don't know why they didn't teach us this. They didn't walk us through this in previous chapters, but it also exists in so many other programming languages, how to split a string based on a given token, right? If our string here had commas, for example, instead of spaces, then we could just pass a comma like that. So this is the solution that I'm gonna submit. Let's see if it works. Maybe the tests are gonna tell us not to use the split, and I might have to cover it in this video, but I don't think it's gonna be that anal about it. It's still loading. Let's give it a second. Okay, there we go. It passed. All tests passed. So I can submit this solution to the server so we can get some credit for it. Refresh, and there we go. Honestly, yeah, but I will, if I forget, somebody remind me in the comments, but I will try to make a separate video that's going to walk us through the solution without using the split method. But the split method it makes this so much easier. Like, you don't have to make this any more complicated than it needs to be. So, and I'm sure maybe in the model solution they did cover it, but let's take a look at it. Let's open this in Chrome. So we're gonna ask me to sign in, so let me sign in. Okay, while that's loading, let's just finish the rest of the readings here. So here at the top of the argument, a quick recap of the data types we've come across so far. We've come across integers, right? Whole numbers. We've come across floating point numbers. The data type in Python is float. So these are decimal point numbers. We've come across strings, right? Peter Python. And we've come across Boolean values. Data type is bool. The data type is str for strings, and it returns true or false. When you call a function, it will only work correctly if the arguments you give it are of the right type. Let's have a look at an example. Here we define a function called print many times. We pass in a message as a parameter. We define this message as the first parameter and times as the second parameter. Right, while times is greater than 0, print that message that many times, decrement times by 1. The function works as expected because if we pass in a string and a integer for the second argument. So here prints hello there 5 times. But if you were to pass in 2 strings like this, hello there Emily and Emily, you get this error, type not supported between instances of strings and integers, right? Because Python is expecting our function here to take in a string as the first argument and an integer for the second argument. So if you pass in, for example, an integer here and a string here, it's going to return the same thing. And if you pass in 2 strings, it's going to return the same thing. Same way if you pass in 2 integers. The problem is that the second parameter times is compared to an integer, 0, on line 2 of the function definition. The argument is given was Emily, which is a string and not an integer. Strings and integers cannot be compared so simply, so an error ensues. To avoid issues like this, you can include type hints in your function definitions. The type hint specifies the type of argument intended for the function. So yeah, so here we can basically tell Python that the first parameter is of type string and the second parameter is of type integer. Now this is, if you've worked with TypeScript, for example, this is something that you can do when you're defining parameters. You can ensure that your function takes in specific parameters at all times by defining what type these parameters are. So here we're defining the type as a string, and here we're defining the type as an integer. This tells anyone, but this is, I think, is a type hint. I don't think it works the same way in Python as it does in TypeScript or in any other language, for that matter. This is more of a hint. So when somebody comes across your function, right? This tells anyone using the function that the argument stored in message is supposed to be a string, and the argument stored in times is supposed to be an integer. Similarly, the return value of a function can be hinted at in the function definition. So we can define here a function and also hint that the return type is going to be of type string. This tells the user of the function that the function is supposed to return a string. Type hinting is literally just hinting about the type of the argument or the return value. It is not a guarantee of type, and definitely not a safeguard against type errors. Okay, so this is what I was saying. If a function receives an argument or returns a value of the wrong type, the function is still executed, but it might not work correctly. Right, so this doesn't limit what is the expectation of the function, right? But we're not forcing Python to only accept a string for the first parameter and an integer for the second parameter, like how you will do in TypeScript, for example. We're just hinting that, hey, in order to use this function correctly, the first argument needs to be of type string and the second argument needs to be of type integer. Same thing for here. We're just saying, hey, expect the function to return a type string. So if you get any other return, then something's wrong. So this is what it's doing here. Okay, so that's what I'm going to end this video. We're about an hour and a half in. I think it's plenty to cover this entire section. Again, if I forget, please let me know in the comments below, and we will revisit this function, this exercise here, and walk you through it while using the .find method instead of this split method for strings. But I think this is way easier, doesn't overcomplicate anything, and it's just easier to read. So yeah, if you have any questions, if you remember from the previous video, pretty sure if I just type in Python here, for example, and if what was the instructions? I'll try to, give me 1 second. Right, so this is what I was talking about here. If you type in directory, for example, and you pass in an empty string, it tells you all the available functions or methods that the string object has that you can use with it. So here we have the capitalize method, which is going to convert our string into a capital sentence. Here we have the lower one, which is going to lower that our string. We have a right find, a left find, a replace, right, and all this other one. And split shows up right here, right? We also have some other interesting one, like starts with, right, which is going to compare whether or not our string starts with a certain character. But the split function is basically like what I explained in the video. It just splits our string based on a given token, and then we can access the returned list and get a specific index like this. So this just makes things so much easier. But you can also find the find method right here, which is what we covered in this chapter here on finding specific strings or substrings inside of a given string. All right, awesome. So hopefully this was a helpful video. If you have any questions, again, leave them in the comments below. If you are having trouble with anything we covered in this video, let me know in the comments below, and I'll try to help you as best as I can or give you resources that will help you more than I can. Solutions that we covered in this video will be uploaded to the GitHub repository. Link will be in the description. Thank you guys so much for watching, and for anybody who's been watching these videos consistently, thank you so much. Just giving me the boost to continue to make these videos. We are in part 4. Next video, we're going to cover section 2 of part 4. Section 3, pardon me, on lists. And We're making good progress. So hopefully, maybe by start of next week, we should be done with part 4. I'll try to maybe put out 2 videos over the weekend, but I don't expect a video to be posted tomorrow, which is Friday, the 8th or the 9th, I think. So videos should be posted on the weekend and then another video next Monday. But yeah, so thank you so much for watching. I'll see you guys in the next one. And again, also, before I close out the video, I apologize. We dropped a lot of frames in this video. And there were instances where frames were dropping kind of crazy. So if there's any choppiness, any freezing, lag or whatever recorded in the video, there's nothing really that I can do about that. Again, VS Code running in tandem with Chrome and OBS just eats up a lot of memory, and I don't have the best computer in the world, so until we can get one, we're just gonna have to power through it. So thank you so much for watching. Thank you so much for tolerating some of these little problems, but I hope you can find some value in these videos that I'm putting out for you guys. So thank you.